Hey, so thanks for joining. Just some general information. If you need an online calculator, www.desmos.com is a great calculator. And if you need to contact me with any questions, my name is April Barton. I'm one of the math teachers here, and you can contact me at april.barton@graduationalliance.com. So we're going to start by talking about real numbers. When you're working with real numbers, you need to know how to talk about them and what makes them special, what properties they have. And so the things we focus on usually are, could they be a fraction? Are they positive? Things like that. We want to look at those special properties, and all those special properties have names. So the first group of real numbers are called natural numbers. And they're also called the counting numbers. And we just had someone join. Thanks for joining, Leticia. Hopefully I said that right. Right now we're talking about real numbers from Algebra 1, Semester 1. If you have a different topic you want to see today, you can send a chat message with it, or once we hit a break point on this topic, we can mention one of the places we'll go to next. So natural numbers, called the counting numbers, are what you learn to count when you're a child. You start at 1, you count up. 1, 2, 3, going forward. So it's basically all the positives. Whole numbers includes all that category. So we're adding on new stuff, but it keeps building up and includes what we already have. The only thing that makes whole numbers different is now they include a 0. Okay. So we could call the number 2 a natural number, and we could also call it a whole number. But 0 right now, we could only call a whole number. Some of the questions will ask you to identify what group it belongs to. So some of them belong to more than one group. Next is integers. So again, it's going to include everything we've seen so far and also add in negative numbers. So all the negative, nice whole numbers, no decimals or fractions yet, but all the negatives, those are called integers. 0 is also called an integer, and all the positives are called an integer. And then the next group is where we get some of these fractions and decimals in. Rational numbers include everything we have so far. So -3, -2, -1, all the negatives, 0, all the positives, but they also have any number that can be written as a fraction. So numbers that are actually written as fractions, those are easy to identify. 1/2 is a fraction. It's considered rational, but it doesn't fit into any of the other categories. It's not natural, not whole, not integers, only rational. But a fraction is also a decimal. If we did 1 divided by 2, we get 0.5. And specifically, that's a decimal that stops. There's actually a lot of different types of decimals as well. Or if we looked at the fraction 1/3 and made that a decimal, it gets 0.333 repeating forever. That's a decimal that repeats. And it can still be positive or negative. Negative 0.5 is still rational. So if you're asked to identify, there's one more group, but we're going to do a quick example problem before we get to the last group because it's kind of different than all the rest. So if you're asked to identify what group does this number belong to, then it may belong to more than one group. If I said negative 15, what groups does negative 15 belong to?
Is that irrational?
It is not rational. Oh, wait, sorry, no, it is rational. Sorry, my brain just quit on me there for a second. It is rational, and it belongs to one more group.
It was the first one that you said, or maybe not.
The first one was natural. That was basically all the positive numbers.
Right.
The next one was whole. That was 0 and the positive numbers. Then came integers. That was negative 0, positive numbers. And then rational. That's everything we've had so far, negative 0, positives, and fractions and decimals that stop or decimals that repeat.
So it would be rational and integer.
Very good. Rational and integer. It fits those two categories. If we said something like, what group does 1.274 belong to? Or groups. What group would that belong to?
Real number.
Starts with an R, but it was
Rational.
Rational numbers. Okay. So there's one last group that doesn't fit really into any of these other categories, and it's called irrational. And irrational numbers mostly come up when you're taking square roots, but of numbers that aren't nice. You know, square root of 25 is just 5. That one's actually a natural number, whole number. It fits in all the categories but irrational. But if we just change that a tiny bit and do square root of 26, and I'm going to show you this Desmos calculator in action. You guys should be able to look at my screen. Let me know if there's any issue with that. It should be actually showing you the calculator right now. So the square root button usually looks kind of like a check mark. And if we type in square root of 26, you'll notice it gives you a big long decimal that never repeats. And technically it keeps going forever. Calculators can't show you every single digit because sometimes they just go forever and we can't have infinite numbers on a screen. So if it's a big long decimal, usually that means it's going forever. So 5.009 or 099 ... that is irrational. Because it's a decimal that does not repeat and goes forever. So if you're ever given a square root number to identify, don't just jump to the conclusion it's irrational. Plug it into a calculator first because it can be tricky. If I said, what group does square root of 625 belong to? You go type it into your calculator. Even though it has a square root symbol, that's not irrational because when you square rooted, it came out as just 25.
Okay.
So, yep. And then I think it also had you like compare two numbers and say which one's bigger, which one's smaller.
Yep.
Yeah. So if you ever need to compare two numbers, the easiest way to do it is to make them decimals. We just had two other students join. Right now we're just talking about Algebra 1 Semester 1. It's the very first lesson in Algebra 1 Semester 1. So if we want to compare these two numbers and we want to see which one is bigger, we need to know, well, what does 1/3 actually mean as a decimal? and we'd go use that calculator again and say 1 divided by 3. Fractions are really just division problems. So the decimal part is 0.33333. Since it already had a 7, that means this is 7.33333, repeating forever. So then which symbol should be here? Is it less than, equal to, or greater than in between these two numbers? Is 7.33 smaller, equal to, or bigger than 7.45?
7.33 is smaller, right?
Smaller, which means less than. Good. So always just change those to decimals because it's a lot easier to compare decimals. Even if you have to do a couple numbers in a list, putting them in decimal format is really the best option. Okay, so that covers that Algebra 1 Semester 1 lesson. We also had a request about solving quadratics by graphing, but we had a few new students join. So if you're interested in a particular topic, you can type it into the chat, or you can unmute yourself and send me, and just tell me, and we'll add it to what we're going to talk about after solving quadratics by graphing. So solving quadratics by graphing is Algebra 1 Semester 2 now. So when you're looking at a quadratic function, that is our U-shaped type of graph. All through Algebra Semester 1, you learned about how to graph a line. The quadratic functions are super useful for physics. It actually can model, if you flip it upside down, it can model like dropping an object, and you can predict how long it takes for an object to hit the ground. And what makes something a quadratic is it always has an x squared. Everything else can be different. You can have, a plus x, you can have a minus, just a regular number, but as long as you have that x squared, this is considered a quadratic. And when you're trying to solve a quadratic, you're trying to figure out where does it equal 0. On a picture like this, the spot where it equals 0 is where it crosses the x-axis. We want to know where x itself equals 0. So if we can find these coordinates, that tells us the information. When you're solving by graphing, I didn't expect you to solve it by hand. You're either going to be given a picture and you just look at the picture and identify what the zeros are, or you use a graphing calculator. So again, I really recommend this Desmos graphing calculator. It's super easy to use. So what you do, let's type this one in exactly, x squared plus 5x plus 4. If it says the equals 0, we don't want to include that part in the graphing calculator. We literally type in just the variables. So we have the keyboard down here, or you can actually type it using your computer keyboard. We have x, and then the a squared is how you get squared. And it was plus 5x minus 4. And it'll bring up the shape. Now we can't see the whole shape. We might not need to on this. If we're looking for the zeros or to solve it, then we don't need the whole shape. But if you want to, there's a plus and minus sign out here to make it zoom out or zoom in. So now we can see the whole shape. And we really just want these numbers where it crosses the x-axis. And once you've identified those are literally the answer. Negative 5.7 comma 0 is one answer, and 0.7 comma 0 is the other answer. So April, do you have any questions on that section? That was one you specifically requested.
There's no questions. I was actually working on that as you're talking about the semester 1 problems, and I passed it with a 66.
Okay. I think you can redo them, or if you want to redo them and it doesn't automatically let you, you can always contact your teacher. I can help, like if you end up wanting a tutoring session with me, that's fine, but I can't mess with your grades if your teacher is Miss Whitehead. She's the one in charge of that.
So you do one-on-one tutoring sessions with your students?
Yes, I can't, I can't help you every day necessarily because there's lots of students, but if you end up really just stuck on one session, then I can help you out with that.
Awesome, because I'm not good with algebra. Algebra scares me.
Scares a lot of people.
Me too.
I opened the first lesson and I looked at it and went, oh, nope, and closed it right up.
I did that with semester 1 when I was in it. It took me two to three tries before I actually finished the class.
I'm in semester 1 and I still have to do a half a semester of algebra.
Mm-hmm. Do you have a specific topic you wanted to hear about today?
The factors.
Okay.
I'm in lesson 1.
Okay. So it looks like you're actually in quarter 2, which is the second half of semester 1. If you already have some credits, we have to split it into a quarter.
Right.
Okay. So let me get to that lesson really quick. Let's see. So not the inequalities. That's the wrong one. Go back.
I'm on the very first lesson in algebra.
Oh, see, I don't have it as a quarter version because I don't teach the algebra as much. Is that relations? 1.1, I guess, for you.
No, it's how to identify the factors.
Slope.
Where they give you like f, they give you the number for f, but you still gotta find the factor of it.
Like this?
Yes,
Something-
ma'am.
Okay.
And they give you the factor of f, say it was like 6 they had on there, but you still gotta solve for x, and that's what I was having problems with.
Okay. So on a problem like this, what they're really asking you to do is find the value of the function when x equals 6. So what they want you to do is actually replace the letter x with 6. This notation, this f of 6, it's kind of a weird notation. It looks really weird, but it's trying to tell you to plug 6 in for x.
Okay. So how would I figure out what would that be the factor?
See, that's where I'm a little confused on what you're asking because the function stuff isn't really related to factors.
Okay.
Looking at the relations and function stuff, there's no factor part. Given the function.
Because I think you're actually my teacher for my algebra.
I don't think. Let me double check. Oh, I show you have Janae Russell. She's a 3rd math teacher.
Oh, okay.
So I'm going to bring up, mine looks a little different than yours. Is it this relations topic or functions?
No, ma'am. I'm not even on that part yet.
Don't look at the 5.1.1 because that's, how about this inequalities stuff?
You figured it out, huh?
No, I think I'm on the actual part of regular algebra because I never passed it. So I never had any credits for it. I have 1.5 classes for it.
Because I show the first thing that you would work on in the Algebra Quarter 2 course. I looked at your individual.
Okay.
It's this relations section.
Oh, okay. Yeah, there it is.
Okay. Okay.
Yeah, see the linear functions, that's what I was having problems with trying to get through on the test and everything. And I went through everything and it was just, I was having a problem with it all.
Okay. So relations is trying to take something in the real world and actually create a math equation for it.
Okay.
One of the easiest ones that you see a lot is your pay. If you're paid hourly,
Right.
then you can actually create an equation so you can figure out, well, if I'm working 30 hours, how much do I make total?
Right.
So if someone made $12 an hour, how would you figure out how much money they're going to have by working 23 hours?
So the X would be the amount that we'd have to figure out for the hour, right? Or how much we made that day, or for 23 hours?
The X would be the number of hours. The X is the variable that changes, and the amount of hours you work can change. You're always making $12. That never changes.
Right.
But the amount of hours changes. So this changing amount is the X.
Okay.
So we have to figure out, what would we do with those two things? Is it going to be like 12 plus X? Do you do the amount you make plus the number of hours you are going to work to calculate how much you've made?
Uh-huh. Wouldn't you times it?
You would multiply it. Good.
This one done. Oh, shit done. She ate, drank.
You guys get lady out?
So 12 times X.
She ain't been out yet, but
Where's that nasty color?
So 12 times X is going to be your equation, and it's Y equals, because Y will be the total amount you make. So if you wanted to know 23 hours of work, you could plug it in. And that's where that f of x notation is useful. You'll see this as
Yes.
part of your problems. If I write this as f of x instead of y, then if I say f of 15, what I'm saying is find how much money you're going to make by working 15 hours.
Oh, okay.
It's just asking you to plug it in and actually figure out, well, 12 times 15, I don't know off the top of my head. So I'm going to type it into a calculator. I'm going to make $180 for working 15 hours.
Okay. So that's how you would figure out with the F and then plug it in, and that's how you would get your answer.
Mm-hmm.
Okay, because that part right there was confusing me.
So does that answer all your questions from the section, or do you have more questions from this relation section?
That helps me out a lot. Maybe I can get through the first test now.
Mm-hmm. Okay. Yeah. So anyone else? Does anyone else have a specific topic from their quarter or lesson that they want to talk about?
I don't. You help me figure out what I needed to figure out.
Okay, good. Anyone else?
If no one else has anything, you could maybe talk about the linear. I think it's linear functions.
Linear functions. That actually is what we just, so linear functions covers a lot, but the beginning of linear functions is what we just talked about. This relation section is the beginning of linear functions. But it does keep going. The next part is rate of change and slope, which can be a little bit difficult. So let's go ahead and cover rate of change and slope. I haven't seen any chat messages saying they want to cover anything, so we'll cover this next part. So when you're working on linear functions, slope. We saw that picture of the quadratic for the student who wanted to know about quadratic functions. A linear function is the first kind of function you learn about, and it is a straight line. So let's take that example we actually just talked about of the amount of hours you work. We can write that equation and we can actually get a picture to see, well, how much am I going to make depending on how many hours I've worked. I'm going to just type it into Desmos for now. When there are graphs, you can always check your work on Desmos. It's a really, really good online graphing calculator. So you could travel along this line and it would actually tell you, if I work 4 hours, I'm going to make $48. Or if I work 3 hours, I'm going to make $36. So it's just a picture representation of these functions, and they're functions that are trying to describe the real world. We're trying to come up with things that are actually useful. But a lot of the times it's just a line or a graph that is kind of hanging out in space, and you need to know stuff about it, even though it's not been given an actual real world application. So when we work on these linear functions, one of the important things you need to be able to figure out is the slope of the line. I'm going to try and make a better graph this time. So the slope of a line is basically how much it tilts. I'm going to use this feature, and I can't draw a straight line very well with a mouse. So the slope is basically the tilt of the line. How much is it tilted? Because that tilt is actually giving us valuable information. On the y equals 12x, the tilt is actually that 12. It's that $12 an hour. So if we're given a picture, but we don't know what it's actually been applied to, how do we find that tilt? There's an equation for slope that is y2 minus y1 over x2 minus x1. So a very generic, kind of vague equation, but it will actually help us find that tilt of the line. So what does each part of it mean? When you have the letter y with a little number underneath, that number underneath isn't telling you to do anything math related. It's not like a squared where it actually gives you a math operation to do. It's literally just to identify that this is the second y value. Every point is an x and a y value. So how do we know which x we're talking about or which y we're talking about? That's where we put the 1 or the 2 on. This is the first x. That's why we put a 1. This is the second x value. That's why we put a 2. This is the first y value. This is the second y value. So once you've identified those, to find the slope, all you have to do is plug each number in and simplify. So for the y2, what number should we actually plug in for y2?
0?
Good, 0. That was the second y value. How about y1?
It'd be -3, right?
Yep, -3. And notice the formula had a minus, so there's still a minus here, but then we had the -3 that was the y1 value.
So that answer would still be a negative.
Actually, it would not. When you have a negative next to a negative, that's going to change it to 0 plus 3.
Oh, okay.
Mm-hmm. Yep, you do have to watch out for that. So then we still have to do the x's. What's the x2 value?
3.
Mm-hmm. And what do we put in for x1?
-2. So that would turn it to 3 plus 2, right?
Correct. So then fraction bars, we have to do everything on top and everything on bottom. We don't want to do any division. We just want to do that addition on top.
So it'd be 3 plus 5.
Mm-hmm.
And
Well,
then
3.
it would be 3/5.
3/5. Yep. So sometimes you do have to reduce that fraction. If this were like 2/4, you'd have to reduce it down to 1/2. But if it can't reduce, that's actually our final answer. That is the slope of the line. That's how much it tilts. And when we don't have, a real world situation to apply it to, we can't really give a good, well, this means. So when there's no real world situation, you just say, well, that's the slope. That's all the information I needed to know for the particular question.
Okay.
So it can be represented a lot of different ways, though. So we did it with a line, an actual picture. They could also, there's 3 different ways to talk about a function that we want information about. We've seen the equation. And I'm going to go back to that y equals 12x because it's good to have a real world one. We saw that the slope was 12 on this because that told us how much we're making per hour. We have the graph, we have the picture of it, and 12 is a really steep slope. So that graph we did on Desmos, and it was just a really steep line. And then we have a table. If we wanted to know individual amounts, if we don't work any hours, we're not going to make any money. So 0, 0, because X was our hours, Y was what we're making. If we work 1 hour, we get $12. If we work 2, we get 24. 3, we get 36. So they can ask you to find the slope given a table instead of that line. If we have a line, we saw we do the y2 minus y1 over x2 minus x1. If we have a table, we actually still use the same formula, but it's harder to figure out what number is what. So let me put up a table. So I wrote my table like this. They can also write it sideways. They are the same thing, it's just the direction is changed. So if they ask you to find slope, though, given a table, we still use that y2 minus y1 over x2 minus x1. So when we use it, though, we have to figure out, well, what's our x1, what's our y1, what's our x2, what's our y2? On a table, it's organized by each thing either left to right or each thing top to bottom. So -10 is in the x column, that's an x value. -2 is in the y column, that's a y value. And since it's the first one on the list, we'll call it x1, y1. You can actually pick any set as long as you label them. You know, if instead of those I used 0, 4, that could be my x1, y1. As long as I pick it and say, this is the first point I want to look at. It doesn't have to be the first one on the list, just the first one you want to be working with. So then you pick a second point, and that's your x2, y2. And as long as you pick any 2 points on this table, it's still going to give you the correct answer. Doesn't matter as long as you label, this is the first point I want, this is the second point I want. So then we go to this formula again and plug those numbers in. So what are we going to plug in for y2 minus y1?
Y2 would be 1.
Okay, so you're looking at these 2 points.
Oh, I was looking at the top.
Okay, that's fine. I just want to make sure we're on the same page. It actually literally doesn't matter. Picking those points works just as well as the ones I had labeled. So y2 is 1. What's y1?
-2.
-2. Good. And then, so because you picked 1 and -2.
So that would make it a positive 1 plus 2.
Yes. Good. So then what are the x values that go with those 1 and 2? What x values?
X2 is -5 and X1 is -10.
Good. And so what will that change to?
Wouldn't it be -5 plus 10?
Good. Okay. So now we do the addition. 1 plus 2 is 3. -5 plus 10 is 5.
And that would be our answer.
And that's your final answer. Okay. So the last type of problem in this rate of change in slope is one where there's an actual application, like it's being applied to a real world type problem. So to become a member of a local nature preserve, applicants must pay an initiation fee of $150 plus their yearly membership dues as shown on the graph. What is the slope of the line joining these points, and what does the slope represent? So if you're given an application problem like this, finding the slope is still the same. Finding the slope is still the y2 minus y1 over x2 minus x1. We just have to be able to read this graph and identify some of these points. So hopefully you can see the points. But we want to actually label 2 of them to use. So this coordinate right here, what would we actually call it? What's the x value and what's the y value?
Depends on which way you're going. The x value could be 2.
Mm-hmm. So because you went down, that is an x value. This line is always your x values. It's always first. So
Okay.
because it hit here, that has to go first in your coordinate. And then we go the other way to get the next value. So what's the other direction?
400.
400. So 2 400. And how about this coordinate?
1 and looks like 250.
I would say 275. 250 would be exactly that line in between 2 and 300. Okay. So if it's kind of a question, you're like, I'm not sure if that's 250 or 275, you could always go pick a point where it hits one of the crosshairs exactly, and then you know for sure what it is. Okay. But we still use the same slope formula. Okay. So what are we going to plug in for y2 minus y1?
Y2 would be 400.
Mm-hmm.
Y2, right?
Y1 is the y value of the first point.
It'd be 1.
1 is the x value of the first point. That's x1.
So it'd be 400 minus 2.
Minus the 275.
Oh, okay.
I did the wrong.
I was confused there by the graph.
Yep. So if, and you know, it kind of got smushed, we can always write it to the side over here and just write the 2 points out so that it looks more like one of the problems we've seen before. But it's always x and y, always x and y. First point, second point. So 400 minus the 275.
So it'd be 275, and then x, and then it'd be 2 minus 1.
Mm-hmm. So this time we don't have to change anything to plus. We just do the subtraction, and we get 125 over 1. Oh, crap. So I think there's a person after me who's a teacher. We share an account. A teacher after me is going to do a lesson at 1:30 for science. Sorry, 1:30 Utah time. and I think they just logged in, which usually screws things up. Can you guys still see my screen?
Yes, ma'am.
Okay. We'll keep going then. If it stops showing, please let me know. It's happened before where it just messes everything up. So this time, 125 over 1, we don't have to leave it as a fraction. 120 divided by 1 is exactly 125. So that eliminates some of our answers. We know the slope is 125, and we just have to decide, well, what does that mean? This time, slope is going to be that yearly membership dues. It was plus their yearly membership dues. The slope is always something that's changing over time.
Okay.
So does that make
So
sense?
the slope is 125, and this represents the annual dues of 125.
Yes, you're paying it every year. So a lot of real world examples are making money. You make $12 per hour. It's over an amount of time. It's changing. Or you're paying someone, they're charging you $60 per hour of labor. You know, your mechanic is going to take 3 hours to work on your car, $60 per hour, you're suddenly up to $180. So this amount over time, that's our slope. It's changing, which is why the 150 was not, because 150 was just a one-time fee, and it's actually where the line would start. If they had put this first point, that's just if I pay one time but then don't pay for a second year of membership, I'm only paying $150 for just the 1 year. So any other questions on that rate of change and slope section? That's also part of that linear functions unit.
What about the direct variation?
Okay, so direct variation. Let me clear out everything I wrote down. And sorry, I had to change some settings so nope. There we go. Okay, had to change some settings so I could actually use my mouse again. So direct variation is just a special type of line. Direct variation is always being through the center of the graph. It's a line that is always going through the middle of the graph. So the green line, like we don't even need to know anything about it. It goes through the center. It's direct variation. If it got moved at all, this line, not direct variation. So what makes direct variation special is because it does go through that center. And it's always going to be an equation, y equals kx. That amount of money you made per hour, that is actually a direct variation equation, where that k, that constant of variation, that's what it will be called, is that $12 per hour. So that's different from like that nature preserve membership we just saw, where you start up at $150 and then have a slope. It's always assuming you're in the center for direct variation. So what they usually ask you to find is that constant of variation. Okay, actually, before we get to finding the k, they'll also ask you what equation works for direct variation. So for direct variation, you can't have any addition or subtraction anywhere else. You have to have y equals a number x, and that's it. So if we had y equals 12x plus 5, not direct variation. If we had y plus 5 equals 12x, still not direct variation. All of this +5 would move the graph around and it wouldn't be in the center anymore. So, or if you had any subtraction going on, if we had 5 minus 2x, still not direct variation. Or if we had some division with addition going on. Oops, I put the equal sign in the wrong spot. No, I would want to put 12 plus x over 4. Sorry, let me fix that. Also not direct variation. So the only thing that's direct variation is this format of y equals a number x. Anything else, not direct variation. So it will ask you to identify, is this direct variation or not? That's the first type of question. It'll ask you to look at a picture and say, is this direct variation or not? And again, that line just always has to go through the center. If it's not through the center, it's not direct variation. And then it will ask you to find the constant of variation.
I'm still confused.
Okay. So we saw the two types of actual real world problems. One was that amount you made per hour. Y equals 12x, that was the function we came up with to say, this is how much money I make per hour. Versus the nature preserve question would have a function that looked like this. I pay 150 one-time fee, and then I pay 125 every year. And we only have just a few more minutes. We're gonna have to wrap this up in like 4 minutes since the next teacher needs to get on. But we'll try and finish up this topic. So the difference between these two things is just this having addition here at the end, this plus 50. This equation is direct variation. This equation is not direct. Direct variation is special because it doesn't have that initial fee or anything happening at the beginning. For direct variation, if you work 0 hours, you're not going to make any money. So when you, when you draw the graph of this, a graph that's direct variation will always go through the center.
Oh, okay.
So this is direct because it goes through the center of the graph. Direct
Okay.
is just a special type of name.
Got you.
The other one's not going to be direct because it's not going to go through the center. The other one was up higher.
Okay.
So not direct variation because it does not go through the center.
Awesome.
Yep.
Now I understand a little bit more.
Okay. I think we're going to be out of time to show how to find the constant of variation.
Okay.
But you can always contact your own teacher for help. I believe you had Janae, right, Ricky?
I think so.
So Janae doesn't do as much individual tutoring. I work full-time for the Graduation Alliance, so I do more tutoring. She works in a regular school, and then
Yeah, because algebra is my only class I have to finish so I can graduate. All my other ones I've been testing out of them.
Mm-hmm. Okay, so if you run into some issues and you do want some individual tutoring, you're free to email me at april.barton@graduationalliance.com. It should be up there. You can't send me a chat message if I'm not your teacher, so you'd have to contact me through email.
Okay.
I do also have a texting number. It's texting only, not call.
Right.
8782. And then normally these group tutoring, those are normally on Thursdays. We had some issues yesterday, so it ended up being moved to today.
Right.
But I run the Thursday session every week.
Yeah, I was wondering about that because I was trying to get in and it wouldn't let me.
Yeah, something was messed up with the link, and so I thought no one was showing up, but it was just they couldn't get there.
Yeah. Well, you helped me out a lot. I appreciate you.
Yeah, thanks for coming. It was great to have you guys all here. If you do need more help, contact me or see you next week.
Do we get credit for this?
So that was 2 questions.
I'm sorry, I apologize.
That's fine. You get like 5% extra credit on an assignment, I believe, for being here. Your academic coach usually takes care of that.
Okay.
And then what was the other question?
I was just writing down your email and stuff.
Oh, okay. Let me know when you're finished. I don't want to shut the whole thing down before you have it.
All right, I got it.
Okay, perfect.
April Barton at graduationalliance.com, right?
Mm-hmm. April Barton. Make sure to put the
April.Barton. Okay,
Yeah.
I forgot the dot.
Okay.
And it is it all lowercase, right?
Yep, all lowercase.
Hey, Bob.
Okay. Have a great day, everyone. I will talk to you guys next time.
You as well. Thank you.
Thanks.
Thank you, April.
Mm-hmm.